Welcome to this explainer. Today, we are taking a massive leap straight into the absolute limits of theoretical physics to demystify some of the weirdest, most mind-bending objects in the entire universe. Seriously, if you've ever found yourself staring at the ceiling, wondering what actually happens when the very fabric of reality bends, breaks, or loops back on itself, you are in the exact right place. Let's get into it. Okay, so take a second to think about this quote. It sounds a bit like poetry, right? But Einstein meant it quite literally. And it is a massive existential bombshell to unpack. See, we all naturally feel time flowing steadily from the past right into the future. But neuroscience tells a totally different story. It turns out your brain is actively tricking you. It takes millions of sensory inputs arriving at slightly different speeds, your sight, sound, touch, and artificially stitches them all together to serve up this neat, singular present moment. So that passage of time you feel, it's really just a psychological filter. It's a survival mechanism crafted by human evolution.
For centuries, we basically just accepted Isaac Newton's idea of absolute time. We thought of time as this invisible, universal metronome, just ticking steadily away in the background, completely unaffected by whatever was happening in the universe. But then Einstein comes along and completely flips the script with relatival time. He showed us that time and space are actually woven together into one flexible fabric called spacetime. And here's the crazy part. If you throw a heavy object like a planet or a star onto it, that fabric actually warps. Gravity literally alters the flow of time itself.
So if time is just another physical dimension that can be stretched and bent, it leads us to this incredibly trippy model called the block universe. Follow me here. Imagine all of reality, past, present, and future, laid out like a giant solid cake. Every single event, from the Big Bang all the way to the end of the universe, is already baked into this block. Your birth, your present moment right now listening to this, and your entire future, they are all equally real, and they all exist right now. You simply haven't arrived at your future coordinates yet.
All right, now that we've totally shaken up your everyday, common-sense reality of time, let's journey into the cosmic anomalies that completely shatter our laws of physics. Because if space-time is this flexible fabric, you have to ask, what happens when you cram so much mass into one tiny spot that the fabric essentially just rips? Well, you get a black hole, and right at the dead center of it lies an absolute monster, the singularity. It's this unimaginably extreme point where matter is crushed to infinite density, and the curvature of spacetime literally veers off into infinity. And look, in physics, when your math starts spitting out infinities, it is a massive red flag that your theory is fundamentally broken. Our best framework, general relativity, basically just throws its hands up in the air and surrenders right here.
And this breakdown creates the black hole information paradox. Think of this as the heavyweight championship battle between our two best models of reality. On one side, general relativity says anything that falls into a singularity is just gone forever, destroyed. But on the other side, quantum mechanics, the ultimate rulebook for the subatomic world, strictly dictates that information can never be fundamentally destroyed. They cannot both be right. This paradox literally keeps physicists awake at night.
So, to keep the peace between these heavily clashing theories, physicists have had to conjure up some wildly exotic alternatives. What if the black holes we see out there aren't actually black holes at all? What if they're basically cosmic imposters that mimic a black hole from the outside, but somehow manage to avoid that pesky, physics-breaking singularity on the inside?
Enter the Fuzzball. Yeah, it's a funny name, but the science comes straight from string theory. Instead of an infinitely dense, impossible point, a fuzzball replaces the singularity with a super-dense, vibrating sphere of tiny quantum strings. From far away, looks exactly like a standard black hole. But up close, instead of an empty pit with a point of no return, it's actually a chaotic quantum thicket. It safely catches, entangles, and stores information right on its surface. It neatly sidesteps the entire paradox without destroying a single thing.
Okay, here's another mind-bending alternative, the Gravastar. This model actually relies on dark energy, that mysterious, invisible force that's currently pushing our entire universe apart. Imagine an incredibly dense object where this repulsive vacuum energy is concentrated right at its core. It pushes outward so violently, so forcefully, that it perfectly counterbalances the crushing inward pull of gravity. So no collapse and no singularity.
But inside a Gravastar, the math gets incredibly weird. Because that inward pull and outward push cancel each other out perfectly, there is precisely zero gravity inside. I mean, if you magically found yourself transported inside one of these bizarre objects, you wouldn't be spaghettified or crushed to death. You would just float, completely freely in a perfect vacuum surrounded by a superdense outer shell. The math even says they could exist within one another, literally like cosmic Russian nesting dolls.
But what about an object where the physics are quite literally upside down? Say hello to the white hole. If a black hole is the ultimate cosmic trapdoor, a white hole is a cosmic geyser. Nothing can ever enter a white hole, but light and matter are constantly spewing outwards from it. And advanced models like loop quantum gravity suggest these aren't just mathematical fantasies. When a tiny black hole eventually shrinks down and dies, it might actually quantum tunnel and explode outward into a white hole.
The math of general relativity perfectly allows for both of these objects to exist. Think of it like this. If a black hole is an ice cream cone pointing downwards, meaning there is an inescapable singularity waiting for you down in the future, then a white hole is a traffic cone pointing upwards. Its singularity already happened in the past. And hey, just because we haven't definitively spotted a white hole yet, doesn't mean they aren't out there hiding in the cosmos.
As we push deeper into the extreme limits of physics, we arrive at a concept that totally blurs the line between hard science and science fiction. If you mathematically unwarp the geometry of certain theoretical black holes, they might not be dead ends at all. They could actually be Einstein-Rosen bridges, which, of course, you know better as wormholes.
But I have to give you the heartbreaking reality check about natural wormholes born from standard black hole equations. If you track their timeline, they are unbelievably unstable. I'm talking violently unstable. They open, widen, shrink, and completely pinch off in a tiny fraction of a second. They collapse upon themselves so incredibly fast that not even light, moving at 186,000 miles per second, can actually cross the bridge before it snaps shut.
So, how do we fix that? To turn a lethal, collapsing space-time trap into a safe, reliable intergalactic shortcut, an advanced civilization would have to meet a very strict theoretical checklist. You need a bridge without a point of no return, where the gravity won't immediately crush you into dust, and crucially, absolutely crucially, you need a way to prop the throat of the tunnel open.
And to achieve that last step, we require something called exotic matter. Now, to be clear, this isn't just dark matter or antimatter. This is a completely hypothetical substance with negative mass and negative energy density. Because its mass is negative, it does the exact opposite of normal matter. It gravitationally repels, it pushes away instead of pulling in.
So if gravity is trying to violently crush the wormhole closed, exotic matter acts exactly like a hydraulic jack holding up a tremendously heavy car. It serves as this ultimate cosmic scaffolding, providing a localized field of negative gravity. It pushes back against the immense, crushing weight of space-time, holding the tunnel steady enough so a ship could safely pass through.
Okay, so this begs the ultimate question. If we can theoretically bend space with extreme gravity and potentially even tunnel straight through it, what does this mean for the other half of the space-time fabric? What are the actual implications of hacking time?
First, the good news. Forward time travel isn't just a fun sci-fi trope, it's a verified fact. Because time is relational, if you accelerate a spaceship to anywhere near the speed of light, your internal clock actually slows down relative to the rest of the universe. If you fly around for a year at that speed, you might return to Earth to find that a whole decade has passed for everyone else. We actually see this proven daily with speeding protons and particle accelerators and even in microfractions of a second with astronauts orbiting the Earth right now.
But traveling backward? Yeah, that's where physics fiercely fights back. The math technically allows it. You could hypothetically drag one end of a wormhole around at light speed to desync its timeline, or maybe spin a cylinder of infinite length. But doing so threatens to create horrific causal loops, like the classic grandfather paradox. In fact, calculations strongly suggest that the sheer energy required to force a backwards time loop would likely just rip a hole in the fabric of space-time before the universe ever allowed you to change the past. It's like a cosmic failsafe.
Which really brings us full circle back to where we started. If we truly live in a block universe where all of time, the past, present, and future, is already baked into reality, maybe our physical inability to travel backward is just a limitation of how our biology evolved to perceive things. Perhaps the greatest mysteries of time and space aren't just out there hiding in supermassive black holes or wormholes, but are locked inside the very way our human minds process reality. It really leaves us to wonder, what else are we going to discover when our understanding finally catches up to the cosmos?